welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge.
Hi everyone, I'm Alice. I'm from ZKM and House of ZK. I'll be interviewing Uma from Succinct. Very excited. They're doing a lot of work making ZKPs more accessible to developers. So very excited to dive into that. Yeah, thank you so much, Uma, for joining us. And I know that you and the Succinct team are on a mission to make ZKPs more accessible for developers and really want to dive into more of that. So really excited, and thank you so much for joining us today.
Yeah, thanks so much for having me.
Yeah, of course. Okay, let's sit. I was wondering if you could go into some more details about the origin story behind Succinct. So what was the intention behind developing a RISC-V based ZKVM and the problem areas that you're trying to solve with it?
Yeah, so we've been building in the ZK space for a really long time. We originally started by building a particular application of ZK, ZK bridging, and we had built with circuits. So we were building with languages like Circom, custom SDKs and DSLs like PONQ2. And honestly, our team was just really tired of that. It was really difficult. It took months to build a particular application. And we kind of felt that it wasn't sustainable and it wasn't really the future of ZK. We quickly realized that the future of ZK was having a general purpose technology where you could just write normal code for any application and then prove it. And we became very bullish the ZKVM approach, where you can just write Rust, you compile it to a normal instruction set like RISC-V, and then you prove it. And we thought that basically ZKVMs are the future, but it's also really important that they're very performant. And the existing options out there weren't super performant, or they weren't super general purpose. You have to learn a specialized language. So we kind of set out to build a very, very fast ZKVM where you could still write normal code. And that's what we built with SP1.
Nice. And then you talked a little bit about how originally you were first focused on the circuit design approach. And there has been some recent debates on whether the future of ZK is more going to be towards circuits or towards ZKVMs. So like over here, you're more of an advocate towards the ZKVM-based approach, but I'm wondering if we could discuss a bit about the trade-offs that exist between both approaches. So maybe like the benefits that circuits may have over ZKVMs, vice versa.
Yeah, so for those who don't know what a circuit is, basically you take your computation you want to prove and you break it down into this very primitive add and multiply gates, and it looks a lot like writing very, very low-level assembly. So the trade-off is that the developer time is probably like 100x. It's 100x more complicated. It requires 100x more expertise. It's just very, very difficult. And with the ZKVM, you can just take the same computation and write it as normal code. So in terms of developer velocity, I think the ZKVM approach is probably 100x better. In terms of performance, circuits are theoretically better because you're hand coding for your particular application, for your particular computation, you're kind of hand coding the specialized circuit for it. So there's less overhead than a general purpose approach. That being said, in practice, we found that our ZKVM is actually sometimes more performant than circuits because we can really optimize it because there's so many applications and developers building on top of it. So you can think of it as like a normal programming language, for example, like JavaScript, where JavaScript inherently isn't a super performant programming language, but because so many people use it, the browsers have gotten really good at running JavaScript in a very optimized way. They do JIT compilation, they do a lot of different techniques, and for us it's very similar. Like, because there's so many people that use SP1 in our ZKVM, we run it on GPUs, so we implemented a full GPU prover. We've had this system of precompiles where you can basically have specialized circuits talk to your main RISC-V ZKVM, and that gives it a lot of performance, and you get the best of both worlds. And there's a bunch of other tricks that is generally difficult for any circuit developer to do because it's just one application, so usually it wouldn't make sense to put a lot of engineering effort into just one application. So we've actually found that our ZKVM outperforms circuits, especially with our precompiles, for the grand majority of use cases that we've tried. I would say the one exception is for client-side proving. If you want to do proofs on your phone, or a really restrictive like environment, like your browser, where you're not able to run, code on a GPU. You're running it in your browser with WASM, or you're running it on your phone, which doesn't have that much memory. Their circuits are still more performant than ZKVMs, but I'm confident that if that became a priority for our team, that we could also do kind of a similar level of optimization to kind of get the performance on par.
And it's great that you're taking that approach of combining the best of both worlds. And now for ZKVMs, even though they're more generalized, we can do more specific like optimizations on there as well. So I think that that's a very great like stride towards, in general, just making it more accessible. And I also wanted to ask you a bit about adoption as well. So, I mean, in recent years, we've seen things like proof generation costs becoming lower, developer experience, like with what Succinct is doing, making the developer experience more accessible as well. Despite kind of these advancements, we're still not quite at the stage where ZK has become mainstream yet for developers. So I'm just curious to hear your thoughts on what sort of challenges and limitations still exist in making ZK more accessible and, for me, mainstream adoption.
Yeah, so I think the biggest driver of proof volume over the next few years is going to be ZK rollups. I think every rollup is going to be a ZK rollup using a ZK VM. And actually recently we announced our OP Succinct integration, where we take OP Stack, which is a very popular rollup framework, we put it in SP1 using their Rust implementation, and then we can convert this optimistic rollup stack into a ZK rollup stack. And I think that's kind of just the starting point of how everything's going to go. Like all these rollup frameworks on Ethereum, OP, Arbitrum, all these things are going to be ZK provable with a ZK VM. And in that sense, I think that's kind of mainstream adoption. If we succeed on that goal, then every user will be transacting on a ZK rollup. They might not know that it's a ZK rollup. They're not going to. Developers still write Solidity. Users still transact with the EVM as normal, but underneath the scenes, it's secured by ZK. And so I think already we're actually on a great path for mainstream adoption. It might not be super legible or super visible to the end user. There's also a lot of other ZK use cases that I'm excited about outside of blockchains. So for example, like attestations, identity, verifiable like image editing, all that kind of stuff I think was really blocked on the existence of ZK VMs. Like you couldn't write all those computations without having a general purpose framework that takes any normal programming language. You were never going to write a circuit for that kind of stuff. Right. So I think now that ZK VMs have actually come into production and are actually fast only over the past year, or really only over the past few months, now there's a lot more of those applications that builders can experiment with. And actually there's a lot of builders experimenting with that stuff with SP1 even today.
Yeah, and I'm personally very excited to see those real-world use cases come up, like even beyond the blockchain context as well. But just going back to OP Succinct, I'm very curious to also hear about like the integration process that devs need to take if, say, they wanted to upgrade their OP stack to a ZK rollup. What does that look like, and are there any sort of like customization options available? You also mentioned that you want it to be like as seamless as possible, so they don't even realize that they are using like a ZK-based rollup. So I'm wondering what that process looks like as well.
Yeah, so the beautiful part about SP1 is you just take Rust, you stick it in, and you can use proofs. And so for the OP stack, we didn't have to do much for the integration, which was very much by design. They'd already implemented their state transition function in Rust. We were able to take that code, stick it in SP1, run it, and do a very lightweight minimal integration where thankfully their stack is very modular and very pluggable. So we could just plug in the validity part, and instead of using the Optimus default proofs, we were able to use the SP1 proofs. So from our end, we actually did the integration with the help of the Optimism team. But in the future, if there's other rollup teams that want to use SP1, I think the integration would be pretty similarly lightweight and pretty straightforward if you have good abstractions, because again, you just take your normal code that you're using for your state transition function. A lot of teams already use Rust, and then you just stick it in SP1 and it kind of just works.
Oh, nice, nice. And also very curious, just transitioning a bit onto the architecture side for SP1. One thing that stood out to me the most was that you guys offer developers the choice of different prover modes. So like, for example, like the Stark prover mode, a compressed prover mode, and Gross16 prover modes as well. So I was wondering, in providing developers that kind of choice, what does that enable?
Yeah, so we have two modes of proving. One is generating Stark proofs. Stark proofs are usually a bit bigger, so they're like hundreds of kilobytes, and you can't verify them on EVM chains because it's too big, that's too much call data. And then there's Grot16 or Plonk proofs, which you can verify on EVM. They're only hundreds of bytes, so it's very cheap to verify. It's like between 200K and 300K gas. We offer those two different modes depending on where you're using your proofs. So if you're using your proofs on Ethereum or another EVM chain, you're probably going to use Grot16 or Plonk. If you're using the Stark proofs, you're probably verifying the proofs like on another device or not in an on-chain context. Generally, we see most of our developers using the proofs on-chain, so most people use Grot16 or Plonk. But we offer both options because just more flexibility.
Yeah, nice. And I do like that idea of providing devs with that choice depending on their kinds of needs or what kinds of use cases they're building. So that sounds all great. Also wondering if we can touch upon, which you briefly mentioned, about the precompile options that you guys have. So maybe just some intentions behind designing an architecture that was precompile centric, and also with having or enabling developers to have their own custom precompiles. What does that enable?
Yeah, so generally what a precompile is it's a specialized circuit for a specific operation, like a hash function like catch-ACK or SHA-256, or verifying signatures like SecP256K1 that talks to our main RISC-V CPU. And the reason you'd use a precompile is that it's much more efficient for that particular operation than having to do it in RISC-V instructions. So you can kind of think of it as in normal programming languages. When you want to implement something really optimized, you implement assembly directly. In ZK world, we implement a precompile. So you can kind of think of it as ZK native assembly. One of SP1's major innovations was our precompile-centric architecture, where our architecture, we did a lot of clever cryptography to make it so that you can have very general precompiles, where you can have precompiles for catch-ACK, precompiles for SHA, precompiles for a bunch of different elliptic curve things. And that's really what made SP1 an order of magnitude faster than other options on the market, because you have these precompiles for these very specific operations that are very frequent in things like proving an Ethereum block. So we have these precompiles, they make SP1 super fast, and it's also pretty easy for developers to add new ones, thanks to like our open source architecture and how, in general, the cryptography behind the scenes and how we've set up our APIs and SDKs. For example, our intern over the summer, he learned everything from scratch. He was a superstar. He's very, very smart. But he added a precompile for the BN254 curve, which is used in Ethereum. And we've had other people and other teams add precompiles as well to SP1. And that can really help accelerate any performance bottleneck. So basically, you write your program in RISC-V, and then if you find there's a performance bottleneck that's something very repetitive that can be accelerated through a precompile, you can add it yourself, thanks to a very flexible architecture, which is pretty awesome.
Yeah, I think that's awesome as well. So thank you for mentioning that. And I also wanted to touch upon some of the other kinds of offers, like product offerings that Succinct has. So there's SP1, and then you guys also offer a proving network as well. And that proving network I know is decentralized. So I'm wondering if you can also touch some light onto the value proposition behind making a proving network decentralized, and what kinds of implications that brings compared to, say, a more centralized approach.
Totally. So for ZK or running SP1, you can do it locally on your laptop. Now, it's not really a fun time because it's a very computationally intensive process. And actually, we've gotten a lot of performance benefits from running it on GPUs, and most people don't have a GPU sitting around in their house. Additionally, you can get a lot of speed benefits by running proving not on one GPU, but across hundreds of GPUs, which we regularly do in our cloud cluster. We have hundreds of GPUs that we help people run proofs on, but usually people don't want to set up that infrastructure. So Prover Network is just a mechanism for anyone who wants to use SP1, who doesn't want to run proving themselves. They can just send us a proof request with their program, their inputs, and then we generate a proof for them and send it back. And it just makes developers' lives easier. It's kind of a positive sum collaboration where they don't have to set up their own infrastructure, and they can pay us, and we can run the infrastructure much more cheaply and efficiently than them, and also save them a bunch of time. Now, a decentralized prover network kind of takes that concept and adds puts it on steroids. So instead of just us running our own GPUs and generating proofs, the idea with the prover network is that anyone in the world can plug in their GPU and help contribute proving capacity for SP1. And today we don't have that. Today it's just a prover network of size 1 where only we are generating proofs. But towards our long-term vision is to build this decentralized prover network where, like I was saying, anyone can join and contribute capacity and kind of participate in SP1 and Succinct and the future of ZK.
Mm-hmm. And in that long-term vision that you have for decentralizing your proving network, I'm wondering if you can talk about the roles within that proving network. So there'd be provers, there'd be people requesting for those proofs, and how exactly you would imagine those proofs to be delegated across the different provers.
Yeah, so kind of the actors in the prover network are the users who are sending proof requests. They generally send a program, they send a set of inputs, and then from that information, you have everything you need to generate a proof. Then you have the provers who are actually generating the proofs, and the biggest question is how do you price the proofs, and also how do you allocate the proofs? And how do you make sure that there's not too much wasted work where, there's not multiple people competing to generate the same proof, because then that's just wasted GPU compute. And also, how do you price the proofs in a way where there's cost competition amongst the different provers so that the end value accrues back to the user and they kind of benefit from this competition. And that's some work we've been doing a lot of recently, and we're pretty excited to share. We have a lot of ideas on interesting cryptoeconomic incentives and mechanisms to price the proofs and allocate them that solve a lot of problems of doing a pretty naive solution. And yeah, we have, some upcoming work that's going to come out on kind of that architecture and design and the mechanism of our prover network soon.
Nice. Very much looking forward to that. And just back onto the topic of choice, specifically for SP1, I know that you guys also offer developers a choice of them aggregating their proofs. So I'm wondering, in what sort of scenarios, because proof aggregation seems to be a pretty big trend across a lot of ZK VMs, in what scenarios is proof aggregation maybe not needed? And what implications does it have when you provide developers with that choice on whether to use proof aggregation or not?
Yeah, so today verifying a proof on Ethereum costs around 200K gas, which isn't super expensive, but it's not, super cheap. For example, on Ethereum, the minimum transaction cost is 20K gas, so it's 10x more expensive than that. With proof aggregation, what you can do is you can take a bunch of proofs, you can aggregate them, and then you can verify 1 gigaproof on Ethereum and amortize that 200K gas cost across many, many proofs. And you can make it so that the actual cost of verifying a proof after you take into account this average becomes much less than 200K. Maybe it becomes around 20K. So if you're a developer and you're really cost sensitive, then proof aggregation could make a lot of sense. If you care about latency, though, for example, you want to get a proof on chain as fast as possible, then aggregation makes less sense, because to have proofs to aggregate, you have to wait some amount of time to be able to aggregate them. Another case where aggregation doesn't make that much sense is sovereignty. So for example, if you don't want to rely on an aggregation service, you want to be able to land your proofs whenever, you want to control that cadence, then maybe using an aggregator doesn't make the most sense. So I think we offer kind of both options, depending on, the specific use case. And for a lot of people, the cost of verifying proofs on Ethereum is not that bad. So, they haven't needed aggregation yet, but maybe, in the next year, gas prices will go up again, it'll become a big theme, and proof aggregation will become more important.
Mm-hmm. And so it really depends on the developers' needs, like what you mentioned with sovereignty, or if they're focused more on cost, latency, just depending on the use case that they're trying to build. Got it.
Yeah.
Nice. And also, I wanted to touch on the topic of open source as well, because all of Succinct's developments, including SP1, are made open source. So I was curious to hear your thoughts on how important you think open source is, especially for the ZK space and even the greater Web3 space.
Yeah, so I think all of crypto is generally open source, and I think there's a deep open source ethos to the ecosystem, kind of from the original days of even Bitcoin, where everything was done in the open. But I think also from a really practical perspective, beyond just ethos, it has to be open source for security, because if we had a ZK VM that was closed source, then who knows what we'd be proving. And so from our launch day one, we've always been open source because I think it's just critical for people to know exactly what are the cryptographic statements that we're proving, and make sure that proof doesn't mean anything unless there's this underlying hard mathematical backing and you know exactly what's going on. So open source is really important. And we also think, the open source community is very nice and very compounding. So there's a lot of teams that have forked SP1, added their own precompiles, tried doing a bunch of optimizations, and we've even merged some of those things back upstream. So for example, the Lurk team, I think now they're called the Argument team. They're a really, really talented team, and they forked SP1. They added a bunch of BLS precompiles, which is really valuable for an ETH-like client. And then we merged those PRs upstream, and it was wonderful because we were able to leverage their work, and performance got a lot better on the Ethereum-like client use case. It went down, I think, by a factor of almost 20 or something like that. So there's like a 20x speed up from their precompiles. I think open source is awesome, or not only needed, not only part of the ethos, but also very practical, helps other teams feel comfortable and good about adopting it. I think the future of a lot of the ZK stuff is very open source for all those reasons.
Mm-hmm. So it definitely helps on the transparency side and also even on the development side as well. Great. And also curious to see, just scoping out a bit about your vision for the ZK space. So how do you see the space evolving in the next couple of years? And I'm also curious to hear about what the ZK endgame really means for you.
Yeah, I think for me, in the short term, the most interesting and highest need consumer of ZK will be blockchains. I think for example, the Ethereum rollup roadmap has kind of needed ZK for a very long time. And there's actually a lot of technical debt that we've accrued by having these systems or rollups in production that are just multi-sigs, not verifiable. I think you kind of have to question, well, what are we replacing? The whole point of blockchains is trustless, decentralized systems. And a lot of the rollups we're on today are not even trustless. So I don't even know if they should be counted really as rollups in the true sense of the word. So I think ZK is a burning problem for rollups and blockchain scaling today, and I think that will be the biggest driver of proof demand over the next year or so, or maybe even a couple years. But beyond that, I think ZK can actually do a lot. I think it's actually this new cryptographic computing paradigm. You have this old generation of cryptography, which was digital signatures that kind of brought authentication to the internet, right? You know who's signing something, and you can verify that with their signature. ZK is really powerful because it's programmable. You can verify anything. You can prove any computation. And with that extra flexibility, now you can start doing things that are more complex than authentication. So you can do things like, a verifiable credit score. You can verify that an image was transformed in this way. You can make sure that prove that not only this person has a particular public key and is a certain identity, you can prove complex statements about their identity. I am this person, I'm in this set, I have these properties, here's my credit score, here's some pieces of information about my nationality, without revealing, all aspects of your identity. So I think those are some of the things authentication, credit scoring, insurance, stuff like that, where today, the only way of having verifiability is through government regulation. But with ZK, you can imagine now you have verifiability through this new computing paradigm. And I think I'm really excited about that on the 5 to 10 year time horizon.
Mm-hmm. And I like how you coined it as the new cryptographic computing paradigm, and how we're able to see the shift because of programmable cryptography. So lots of exciting new developments along the way. Just on this topic of vision, I'm wondering if you can also speak about some long-term goals that you see with Succinct and how you see Succinct evolving in the next, say, 5, 10 years.
Yeah, I think, so far we've been really focused on delivering value to real customers and real users, and I think that's going to continue no matter what. So even in the short term, our goals are to make SP1 the best ZK VM possible, and because we kind of have this pretty simple thesis that ZK is really important to blockchains and scaling, the future of ZK is ZK VMs, and we want to build the best one. And so SP1 is the fastest ZK VM out there today, and we want to keep on continuing that and making it faster, having better performance improvements, making it work for client-side proving and server-side proving, and just making it a tool that any developer can really use as easily as possible for as cheap and fast as possible. So I think that will always be a goal of our company. And then I think the other biggest focus of our company right now, well, there's two things. One is like the prover network. So basically taking SP1 from a piece of software to something that anyone can help contribute capacity towards and building this like global proving cluster instead of just us doing all the proofs. For all blockchains. And it turns out that's actually pretty important for a lot of our customers because in blockchain systems, it's important things be decentralized. And so it's also important to them that proving is decentralized. There's no single point of failure. And then finally, I think we're just really focused on adoption and getting all those really exciting use cases out there and built. So for example, I think every rollup will be a ZK rollup. And OP Succinct is a great start towards that. But there's a lot of other stacks that people use, a lot of other rollups people use, a lot of other VMs that are not EVM that people use. And getting all those state machines proven in SP1 is a big focus. And all the other use cases that I talked about that kind of go beyond blockchains, I think it's finally possible to start working and iterating on them. So helping support those builders working on these kind of like more novel, far out ideas is also a big area of focus for me and something I am very personally excited to help those builders and founders work on.
So we're beginning to see this sort of ZK mainstream adoption come here, and now it's just about like kind of embracing towards it. So very exciting times again that we're seeing. And yeah, thank you so much, Uma. Really appreciate you for being here today, and also really loved hearing not only about the what for what you're building, but the why behind it and the vision behind it as well. So really appreciate it.
Yeah, thank you so much for having me.
Yeah, thank you.